So you sent over some really thought-provoking stuff this week, all around this massive idea. Could humanity, actually rule the galaxy one day?
Yeah, it's definitely moving beyond just pure science fiction, isn't it? Some of the research points towards, well, maybe not ruling, but certainly having a presence.
Right, a presence. And it seems like the starting point in a lot of this material is figuring out where we even are, technologically speaking. The Kardashev scale kept coming up.
Exactly. Nikolai Kardashev's idea. It's basically a way to rank civilizations based on how much energy they can use. A cosmic energy ladder, if you will.
Okay, so let's break that down based on the sources. Type I is planetary, right? Using
Right.
all the energy on your home planet.
Precisely. Mastering everything, weather control, earthquakes, harnessing the planet's core heat, that level of control.
Okay, wow. Then type 2, that jumps up quite a bit.
Oh, massively. Type 2 means harnessing the entire energy output of your local star.
Your whole star, like building something around it, a Dyson sphere.
That's the classic example, yes. A Dyson sphere or something equivalent. Capturing practically every single watt the star puts out.
And I guess logically type 3 is.
Galactic. A civilization that can tap into the energy resources of its entire host galaxy. Billions and billions of stars. Scale is just staggering.
The truly mind-boggling. So based on the research you shared, where are we now? I saw one estimate from Kaku.
Yeah, Michio Kaku estimated us around type 0.72 back in 2011. So we're still firmly type 0. We haven't even mastered Earth yet, not by a long shot.
Right, 0.72. We still got a ways to go just to get to type I. But one of the papers, Reynolds, I think, suggested we might actually reach type I relatively soon.
Yeah, that 2020 paper, it projected maybe 100 to 200 years to reach type I status, which sounds fast, but it depends on certain breakthroughs.
What kind of breakthroughs are we talking about?
Well, the big ones mentioned are things like viable fusion power becoming widespread.
The dream energy source.
Exactly. Plus really advanced solar collection, maybe orbiting power stations, things like that. And also AI playing a huge role in managing those complex energy systems efficiently.
So basically, get our own house in order energy-wise first. That's step one towards the stars.
That seems to be the consensus in the materials, yes. You need that planetary energy mastery before you can really think bigger.
Okay, right. But then, assuming we manage that, how do we leave the nest, so to speak? Getting out of the solar system seems like the next giant leap.
It absolutely is. Our current rockets, even something advanced like Starship, which was detailed in one article, they're great for getting around the solar system, but interstellar distances, they're just too slow. Chemical propulsion has its limits.
So we need something fundamentally different. What did the more theoretical papers suggest? Relativistic propulsion.
Yes, that's the term used. Propulsion capable of reaching significant fractions of the speed of light. We're talking completely different physics.
Like what? What are the actual candidates?
Well, a few concepts pop up repeatedly. Nuclear fusion drives, for instance. NASA's done simulations, apparently, showing much higher thrust and efficiency than chemical rockets.
Fusion. Powering the ship itself. Makes sense.
Then there's the really exotic stuff like antimatter propulsion. Theoretically, it's incredibly powerful, the most efficient fuel possible.
But making and storing antimatter sounds difficult. And maybe dangerous.
Extremely difficult, yes. That's the major hurdle highlighted, a huge technological challenge. And then you have ideas like light sails.
Ah, yeah, the Breakthrough Starshot project was mentioned. Pushing sails with lasers.
Exactly. The 2018 Parkin piece laid it out. Powerful lasers based on Earth or maybe in orbit, pushing these tiny ultralight probes. Their goal is Alpha Centauri in about 20 years travel time.
20 years to the nearest star system. That's still a long time, but vastly faster than current tech. But those are tiny probes, right? Not people.
Correct. Tiny robotic probes. Scaling that up to carry humans or even just larger equipment is another massive challenge. And even at, say, 20% the speed of light, crossing the Milky Way would still take hundreds of thousands of years. The distances are just immense.
So the tyranny of distance. How do the sources suggest we overcome that, assuming we get the fast ships?
Well, this is where it gets really interesting and maybe a bit strange. Several possibilities are explored. One is generation ships.
Like giant arcs, carrying communities through space for centuries.
Basically, yes. Self-contained worlds where generations live and die en route to a destination.
Feels very sci-fi, but maybe necessary. What else?
Cryosleep, or some form of suspended animation. Freezing people or putting them in stasis for the journey. That's a common theme.
Right, waking up centuries later.
And then the most transformative idea mentioned in some of the futurist writing is Well, leaving biology behind.
Uploading consciousness?
Yeah.
Becoming digital?
Something like that. Post-human digital minds. Beings that wouldn't be limited by biological lifespans or the physical needs of a human body, they could potentially travel for millennia.
Wow. Okay, so becoming galactic might mean not being quite human anymore in the way we understand it now.
It certainly raises that possibility. The biological form might be too fragile, too limited for interstellar scales. It suggests a fundamental transformation might be necessary.
Which kind of naturally leads us away from just the tech problems, doesn't it?
Yeah.
The articles also brought up the politics, the ethics of it all.
Oh, absolutely. Even if we could physically spread across the galaxy, how would we manage it? Imagine trying to govern colonies light years apart.
Yeah, communication delays alone would be huge. Would Earth even be relevant? Would we need some kind of post-national identity, a unified humanity?
That's a central question raised. Could our current political structures, our national rivalries, possibly survive on an interstellar stage? It seems unlikely. You'd need unprecedented cooperation.
And what if we're not alone? What about encountering alien civilizations? The astrobiology papers suggest life could be common.
Right. How do you handle first contact, especially if they operate on totally different timescales or under different physical laws? How do you resolve conflicts across interstellar space? The challenges are immense.
Some pieces touched on AI potentially playing a role in governance, managing that complexity.
Yes, the idea that perhaps only a very advanced AI or a network of AIs could handle the sheer scale and complexity of coordinating a galactic civilization, which of course raises its own set of ethical questions about control and autonomy.
It really does. And the authority question. Would colonies stay loyal to Earth?
Yeah.
Or would they inevitably become independent? History on Earth suggests the latter.
History certainly provides some cautionary examples, and that brings up the deeper ethical point, the Carl Sagan warning that was quoted.
About getting our own act together first.
Precisely. That we need to achieve some kind of wisdom and harmony here on Earth before we try exporting ourselves and potentially our problems to the cosmos. Unchecked ambition, Sagan warned, could be disastrous.
Yeah, the potential for screwing things up on a galactic scale is sobering.
It's described as potentially the greatest cosmic tragedy if we expand without that wisdom.
Okay, so we have the immense technological hurdles, the huge political and ethical questions, and then there's the silence.
Yes, the elephant in the cosmic room, the Fermi paradox.
Which, simply put, is, if the galaxy should be teeming with life and potentially advanced civilizations, where is everybody? Why don't we see signs of these galactic empires?
Exactly. Given the age of the universe and the number of stars and planets, statistics suggest someone should colonize the galaxy by now. But we see nothing definitive.
And the main explanation discussed for this is the great filter idea.
It's one of the leading hypotheses, yes. The idea that there's some incredibly difficult step, some filter in the development, from simple life to a spacefaring, galaxy-spanning civilization.
And this filter could be behind us, meaning complex life like us is just incredibly rare.
That's one possibility. Maybe the jump from non-life to life, or from simple cells to complex ones, or maybe developing intelligence itself is the really hard part we've already passed.
Or the filter is ahead of us.
Which is the more worrying thought explored in some sources, that perhaps civilizations inevitably hit some wall before they reach type 2 or 3.
Like, they discover some technology that destroys them. Or they run into resource limits or political collapse on a planetary scale.
Those are all possibilities discussed. Self-destruction, societal collapse, maybe even technological stagnation for some unknown reason. Or maybe
something else.
Maybe advanced civilizations just become undetectable to us. They transcend into forms or dimensions we can't perceive, or they choose not to interact. They go dark in ways we don't understand.
Which connects to the search for technosignatures, right?
Right.
NASA's looking for evidence.
Yes, exactly. The right paper you sent detailed NASA's technosignature working group. They're actively thinking about how we might detect signs of alien technology.
Not just radio signals, but like massive structures, weird heat signatures.
Right. Looking for anomalies, Dyson spheres blocking starlight, evidence of stellar engineering, unusual atmospheric compositions, maybe even signs of AI activity on a massive scale, things that shouldn't be there naturally.
And the current status, according to those reports.
Still, nothing definitive, lots of interesting candidates, but no smoking gun proving an alien technological footprint. The silence persists for now.
So, It leaves us in this really profound place, doesn't it, looking at all this material?
It really does. Either we're potentially first, or at least incredibly rare, destined perhaps to be the ones who finally break through the filter and spread into the galaxy.
Or there's some barrier ahead, something that stops civilizations like us from making that leap, and we just haven't hit it yet.
Those seem to be the stark possibilities laid out. It underlines that reaching for the stars isn't just about bigger rockets or more power.
No, it seems it requires something more. The sources really emphasize wisdom, unity,
Yeah.
things we struggle with right here.
Absolutely. A shift beyond just conquest or expansion for its own sake. A maturity, perhaps, that we haven't yet fully achieved as a species.
Well, this deep dive has certainly given us a lot to think about, from Kardashev scales to great filters or hard. And maybe the final thought for everyone listening is this. As we dream about galactic futures, maybe the most important frontier isn't just outer space, but also, our inner space, the choices we make right now.
Well said. The gravity of those choices might determine whether we ever truly reach the stars at all.